In this application, we're using the Acuity AP820-40 laser line sensor, and here you can see the laser line. And this is the -40 model, and so that means it has a 40 millimeter depth of field, and then it's a 20 to a 27 millimeter laser line width. And with this model, we're going to have, in the X direction, we will have a 40 micron resolution, and of course in the Z direction, we will be about roughly 24 microns of linearity to make this measurement. These are dark round spheres, and we're going to show that we can measure this diameter very accurately. And so we're just looking at the tabletop, and as we come up onto this first sphere, let me just shrink this down a little bit so you can see it. So there's that first sphere. You're seeing the diameter, and here's the tabletop. We're getting a really good clean signal. And as we come up to the smaller second sphere, also good signals. We're not going to have any problem at all on this surface making these measurements. And just some of the existing tools we have, we do have a circle fitting tool in the Acuity View software, where we can come through and set up the diameter settings of this. In fact, let's just set it up in this way. And it's very hard to see there, but we are measuring the radius. So let's put this into a result screen. So here's the radius. So we're roughly reading about 12 millimeters. Excuse me, that's about 18 or 19. It's about 19 millimeters. I actually did hand mic it, and I believe I got 19.53 millimeters roughly. So there is a way to come in here where we can put in a multiplier on the center, and so we're going to make that multiplier 2, so that radius will turn into the diameter. Let me just change that real quick. Back to 1, and the radius offset, radius multiplier, I'm sorry, is right there. It's 2. So we are measuring about 19.5 millimeters. And you can see right there we're capturing that peak height. And as we go down to the smaller targets, we're looking at about a 9.3 millimeter diameter. There's about a 9.8. And here we've got about a 6.3 millimeter diameter. Just to also give you an idea, I mean, we do have a tear and an offset, so we can come in here and take a known number. In this case, I believe it is about 19.65, and so we can actually put a tear in here and force it to a known number. We can also come in here and let's take a look at this in 3D view to give you an idea of what the laser's really seen. And so as we scan across here, you know, the camera's on the back side there, so we lose the back part of that scan. But as you can see, we're getting very good data as we use a little small encoder. And I would imagine in this application, you're going to take an encoder, you're going to take the data, and then you're going to look at that max peak diameter measurement to give you that. This will also show some of the flaws in the surfaces. If there are little, I did notice there are some little nubs in here, and we would actually pick some of those measurements out. So here you can see there's that little nub right in there. I don't know if you can see it on this resolution, but we will pick up any surface flaws. So the advantage of using a laser line versus a through beam is through beam will give you 2 points. We're going to be putting 580 points by 640 pixels across there. So we will measure not just the max peak, but we'll also see any flaws or deformation also in this sort of measurement. And as you can see from looking at this, the laser likes its target. We don't see any errors. We don't see any spikes. So we should be able to get a very good measurement on this application.